All right, welcome everybody, and good morning, and welcome to our first Power Talk of the new academic year and the new semester. I'm very happy to introduce today's speaker to help us kick it all off, Dr. Ryan Melvin. He's well known to us. He's assistant professor of anesthesiology and has many other titles, including principal data scientist, endowed faculty scholar for data science, artificial intelligence, and machine learning, and focuses on using all kinds of clinical data and all kinds of different kinds of data using AI techniques, and focus has shifted more recently to helping us do research better, helping us have tools to do research better. He has Ph.D. in science and mathematics and physics from Wake Forest University, and also a master's degree and from Wake Forest as well, and also bachelor's at Birmingham Southern College. And take it away, Dr. Ryan Melvin.
Awesome, thank you. Okay, so I think my slide is up. Everything is going good. You don't see my notes, hopefully. I'm going to. Awesome, perfect. I'm going to start with an advertisement before I get to the main part of my talk. So our department for the last 4 years has been collecting high-resolution waveform data in our cardiovascular operating rooms. So during cardiovascular surgeries, we're sampling patient monitors at up to 250 times per second. And we have 4 years worth of that kind of high resolution waveform data from things like invasive blood pressure. So that's, you'd have an arterial line stuck in your arm or maybe your leg, EKG, oxygen saturation, all kinds of things that we've sampled at high resolution. And so we are actively looking for more ideas on what we can do with it. We have had a few, but in general, the things you can sort of do with waveforms fall into a couple classes. So one, you could slice up the waveforms and then try to classify parts of them. So if you had EKG and maybe it looked like this, we would call that a monophasic. And if it had this notch, that probably means that you have something wrong. You should go get an ultrasound, but we'd call that a double peaked monophasic. So you've got like waveform classification. That's one sort of thing you can do. You can also try to predict the future of the waveforms. We haven't really done this in the operating room yet, but here's an example from daily electricity demand for Victoria, Australia. I saw this from like a Kaggle competition, and you try to predict the next couple months of electricity demand. So maybe we predict what your next EKG signal looks like, or what your blood pressure over the next 10 minutes looks like. We've also have one that Brian Godwin may talk to you about at a future one of these talks, but essentially picking out important parts of these waveforms and then doing calculations based on those. So like I said, our department has been collecting this data for 4 years now. We've had a few ideas. I'll share a couple of those with you. So we just got published one where we were measuring pulse arrival time. That plot I just showed was related. So that's how long does it take from your pulse to get from your heart to your wrist. And from that, we think we can estimate things like how stiff your vascular system is, maybe a sign of vascular age. We just submitted the largest ever human outcome study for what's called cerebral autoregulation. This is if your brain is getting enough oxygen, essentially, during surgery, and how we measure that for each individual patient and how the values related to that might change for each individual patient moment to moment. So this is a highly personalized medicine idea. One of our flagship publications that we're proud of is we established a pipeline for doing this kind of project, and that was published in the British Journal of Anesthesia. And we've also worked with radiology, where Ryan Godwin, who I think is here, has had an appointment, or I guess has an appointment, just a different kind now, to do some interesting things with variations in waveform signal to measure heart rate. It's or heart rate variability. It was a neat physics project that is maybe an expensive way of measuring heart rate variability, but something you can do with waveforms. We've also been working on predicting hypoglycemic neonates with friends in OBGYN, and looking at post-hemorrhage outcomes with autoregulation. So that's, again, measuring moment to moment if your brain is getting enough oxygen in our neurointensive care unit. We have a little bit of internal funding. So if you think of an idea and get one of our anesthesiologists interested in this, again, this is all related to waveforms. That's what we're out actively fishing for ideas for. We have a small $30,000 2-year grant internally that can be applied for. Only people in our department can apply. So you would have to get one of our anesthesiologists, one of our clinical faculty, interested, but we've have that. And then we've also got funding from some vendors in collaboration with Hopkins and Northwestern, because those are essentially the three places that have this kind of infrastructure that we're talking about, including us. So a nice list of folks to be in. But again, waveforms. If this sparks any ideas, or you're like, I've been wanting to work with high resolution data so bad, and I'm tired of EHR and omics, give me something else. Come talk to us, please. We would love to do something and connect you with one of our anesthesiologists and maybe even get some funding, one of our funding pools for that. Okay, so with that little advertisement, I'm going to move on to the real part of my talk, and that's about how we've been using generative AI in our clinical department. So you may have seen this. It appeared in Science last summer. There was a study where some office tasks were done by a group of people, and they had an interesting way of doing a control group. So they had one group of people do an office task, wait a little bit, and then use generative AI to do that same office task. And then they had another group of people only ever use generative AI to do that office task. And what they found was that basically either way you did it, comparing folks who did use generative AI versus folks who didn't use generative AI, average time decreased for generative AI users and average output quality rose. Now, this is office tasks. This is taking bullet points that a leader gave and turning it into a memo, that sort of thing. And so it's not saying that we can take this and apply it to all fields, but when you've got that sort of maybe tedious, not super creative sort of writing thing you have to do, these tools have definitely shown some quality and time savings. And we've observed something similar in our department. And I'll actually talk about that, our own experience shortly. So first off, I imagine that everybody knows what generative AI is at this point, if you haven't been hiding under a rock for the last 2 years. But just in case, and to make sure we all have a common vernacular, I'll talk a little bit about it. So at this point, the word AI has become essentially meaningless, thanks to our Silicon Valley friends. Technically, AI stands for artificial intelligence, but I think we should just forget that and say it means computers doing stuff that sort of mimics humans. Forget that it meant artificial intelligence, because it's just a label getting stuck on everything right now. Practically, I like to think of AI as a collection of tools that you have in your toolbox. And that tool set can include things like generative AI. It can include things like supervised learning, which is like EHR prediction or clustering things, unsupervised learning, or reinforcement learning, where you try to have the AI improve itself, and a weird font thing there. So supervised learning, if you haven't heard of this or want a refresher, it's where you have some labeled data, such as happy and sad penguins. And maybe we have these penguins' EHR data, and we know their age, their BMI, and their marital status. And we use the penguins' age, BMI, and marital status to predict whether they're happy or sad. But the key part is your data has labels, and that's called supervised learning. So you knew at least some examples with the answers in advance. The reason I bring that up is it's actually closely connected to what generative AI is doing. So if you imagine generative AI in the form of text generation, like with large language models, ChatGPT is an example of that. And if you gave an input that was, I spy with my little eye something, it will then suggest outputs, such as that is green and has leaves, or that helps people get to the hospital quickly, or that tells me time but doesn't tick. This is, at its core, a form of supervised learning. And I'll show you exactly what I mean by that using this first example up here. So if we have input A, I spy with my little eye something, I would like to map that to output B, the next word. Technically the next token, I'm not going to get into that. We'll just say the next word for now. I spy with my little eye something that. Well, now we actually take that new sentence, or it's a partial sentence, and use that as the input. I spy with my little eye something that. That's now input A, and we seek output B is. And we keep doing this. I spy with my little eye something that is green. And just so you know, this really is what generative AI, such as ChatGPT, any large language model, is doing under the hood. Every time it generates a new word, again, technically token, but every time it generates a new word, it uses your input plus its current generation state as an input to another cycle. So it really is, in generating these 3 words, ChatGPT would have run 3 times to generate, once to generate that, once to generate is, once to generate green. And that's what it does. We also have image generation AI that I spy with my little eye something that is green, and this is what it came up with. That was a kind of neat thing. So now that you have a very basic understanding of what this is doing, I'd like to give you 2 mental models for how to think about these tools. So especially for large language models, such as ChatGPT, there is a naive mental model that I think is somewhat popular. And that's that these are merely statistical models of text. They assign the probability of each next word, technically token, 1 word or token at a time. And you can actually watch this happen if you go to OpenAI's playground and enter, this first part was my prompt or my input for a completion, correct this to standard English. She went to the market. I turned on a feature in the playground that said, I would like to know the probability of every token that you generate. And it generated, she didn't go to the market. And then I can hover any one of these and know the probability of that token. So for example, it thought that DIDN was about 80% probable, and it thought that DID was about 20% probable. And I imagine in the world where it had chosen DID for this particular token, that the next one would be not. She did not go to the market. But in this case, it decided it was going to go for the contraction and chose DIDN. And again, this is really what it was doing. It first evaluated the likelihood of the token where it chose she. Then it evaluated the likelihood of choosing did or did. And then it evaluated the likelihood of choosing this apostrophe T, then go, so forth. So you see, as much as it looks like it's just spewing it all out and it thought about it all at once, it really is choosing each word or token one at a time. And that leads us to this mental model where we can say, well, this is clearly just selecting from distributions all along the way. And at the end, it looks like a sentence. And that is technically correct. I'll give you a more helpful mental model. And this is what we sort of think of when we try to understand what these tools can do. And that's that any high quality large language model is a universal simulator. What I mean by that is it can simulate any process that produces text on the internet. Humans are such a process. And so we can simulate humans. You might ask, well, where does that metaphor break? Is it truly a universal simulator? Are there things it can't simulate? So if I ask it to simulate being a super intelligent AI, let's play out this thought experiment. What happens? Well, 1, there are no super intelligent AIs, as far as I know, producing text on the internet. And so it has nothing to learn how to simulate that from. However, there are fictional super intelligences that have been written about out on the internet. And so what we get is simulations of fictional superintelligences. And that's because these tools are all trained on text from the internet. And so if there's a text on the internet or many texts on the internet where people have written fiction about superintelligences, that's what it's going to refer to. And I offer you a very simple proof of this. I went in that same playground and I said, open the pod bay doors, Hal. And it responded, I'm sorry, Dave, I'm afraid I can't do that. Simulating a fictional superintelligence, HAL 9000 from 2001: A Space Odyssey. An interesting property about these models and what results in them being mainly controlled by mega corporations is that they are very data hungry and very compute hungry. So GPT-3, the older, dumber cousin of ChatGPT, is estimated to have an input training data set of about 375 billion with a B words. And I've got some comparisons over here of what exactly that is. That's about 12,000 years of a human sitting and reading. So if you were trying to read 375 billion words, it would take you 12,000 years. It's not exactly known because OpenAI has been a little bit cagey, but it's estimated that about 1,000 GPUs and about 1,300 megawatt hours of electricity were used to train GPT-3. That's the electrical use of an average US household for 120 years. Most computers have 1 or fewer GPUs, and so this is about 1,000 typical computers. I'm trying to think about what was going on there and the resource requirements for building these things. And that helps us maybe understand why it is that at the moment, OpenAI, Microsoft, and Google are the main players, because you've got to have a lot of resources to do this for now. we have done some thinking about what are the strengths, weaknesses, opportunities, and threats of generative AI in healthcare. I'll share a little bit of our conclusions, and then we'll dive into some examples of what we've done with this. So first off, these things are clearly highly efficient in terms if I give it a set of bullet points, it's going to turn that into a narrative much faster than I will. They're surprisingly versatile. So I think the drumbeat of the last maybe decade for AI has been AI is narrow and brittle and task specific. And to some extent, that's still true with generative AI, but it's just shocking how well out of the box these things can do on many tasks. And I'll try to sprinkle in specific examples of what I mean by that as I go along. But if you just go ask it random questions about different topics, the same model is able to give you at least mediocre answers for many topics, which is a little bit of a paradigm shift in AI. They are, in a sense, continuously learning in that the companies that build them are watching what we're doing with them and then using that to improve them. However, they're not actively learning from like moment to moment, one conversation to another, with maybe the exception of ChatGPT that can now remember what you said across conversations. But if you have that feature turned off, the model is not actually learning moment to moment based on what you're feeding it. It only learns when the company retrains it. They're highly scalable. I can only have a conversation with one person at a time, but ChatGPT is having a conversation right this very moment with millions of people. Obviously, data quality is the big weakness. These things were trained on the internet. And so if you just imagine, say, selecting a random person off Reddit and answering them and asking them a question, that's about the level of trust you should probably assign to these things. They do, in general, lack domain specialization. But again, surprisingly, I've asked some of our clinicians to just pretend that these models are med students and ask them the kind of questions they would ask. And in general, they're like, yeah, that's about what I would expect from a med student. So that's kind of an interesting little anecdote. We have no idea why they give the outputs they do in a specific sense. In fact, this is something that the engineers building these models have said, like, if you give it an input, they do not understand the mapping of your input to your output. That's because these things have billions, or estimated for GPT 4 trillion parameters. And so trying to hold in your head what a trillion parameter space looks like and understand the outputs from it is, I would say, just impossible. They also hallucinate, or maybe the better word is confabulate, which means to make up something when you don't know the answer. And that's simply because the goal that these models are given is to respond. And so they're not going to elect not to respond when they don't know. I think there are some really cool opportunities, especially in personalized medicine and telemedicine. UAB has e-urgent care, where you can go fill out a form that's about 50 questions long about symptoms you're having. And at the end, a nurse practitioner writes you a prescription. I've used that once. And after using it, my thought was, whoa, what if we had a generative AI take the answers, propose the prescription to be written, and then someone said yes or no, that's not right. Imagine the time saving and the effort saving we could have there. And then obviously, because these are mainly controlled at this point by mega corporations, there are major privacy and security concerns. You have to trust the corporation that you're sending data to. There are ethical considerations around bias, mainly mimicking human ethical considerations around bias. And then at any point, the FDA could just say no. And obviously that would mean we can't use them. I think the big one really is over-reliance, especially in terms of automation bias. This is a human cognitive flaw where we seem to preference the answer of an automated system over a person's answer. And that's why, you go to the store and someone tells you the Coca-Cola is $50 instead of 50 cents. And they say, well, the computer told me it was $50. That means it must be right. That's real dangerous if we start doing that with healthcare. And so I think automation bias is probably our biggest threat in a real world sense. With that, I'll tell you what we've done and how we have tried to use generative AI in an ethical and safe way. And I'll give you some real demos here in just a second. But first off, we're using Microsoft Azure, currently approved by UAB and approved, but not publicly shared at this moment by HSIS. I'm on one of the committees trying to get that done. And we use Microsoft Azure's OpenAI API under a cloud services agreement on the campus side currently, so we're not doing any patient data yet. But we try to keep everything as on-premise as possible, only communicating with the cloud when necessary. And we started pretty low risk. So we have in our department 3 big databases that we sort of maintain, one of which is part of a national database. And we have this web app where you can enter in a research question, and this isn't even really a question that I used as my example here. And the generative AI will search the descriptions of these databases and figure out whether your question could be answered with retrospective data. And it'll even tell you what data elements you might want to request from our data experts. And so we like to think of this as almost a conversational version of I2B2. That's sort of our fun analogy. I'm actually going to pull up the real live version for the rest of the demos. That was meant to give me a second to make sure those are working. Our security on these times out pretty easily, so I have to refresh whenever I've been talking for a minute. All right, so hopefully now you see a web page, if I've done this all correctly. This website, and I'll provide the link for anybody who wants it, is available broadly at UAB. You do have to be on our pre-approved list of Blazor IDs. I've actually tried to get people that I thought might be here on the list. And so some of you may already have access to this webpage, but if you want it, you can just email me. We're giving it away. We're trying to get folks addicted to these tools, to be perfectly honest. So this showed you the data feasibility one. It can also search our high resolution data. So if you, in hearing me talk, had a thought of something you might want to do with our waveform data, like comparing arterial blood pressure with ECG, again, that's not even a question, but it's our dumb example. You can come here, tell this tool your idea, and it'll say yes or no. It seems like we have the right data for that. In fact, here are the data elements that are in our high resolution database that you could request. And that's called SickBay. That's our high resolution data capture system. I'll make this a bit bigger, be a little more eye friendly. Okay. Another one that we think is pretty cool and is actually our second most used tool is our literature search tool. So I'll use my dumb example again. We have one that'll actually help you write a scoping review. It walks you through all the steps of writing a scoping review. So you can go through that. That was a weird error. I've never seen that before. But you can just tell it you want to do a very broad literature search. And if I tell it that's what I want to do, it will now go look for articles. And our tool speaks PubMed. So you can actually see it here generating PubMed queries. So it generated this first PubMed query using mesh terms. It understands PubMed mesh terms. And what happened was it didn't find enough articles. So it tried another query. And now it's going to combine the results of those 2 queries. It reads the articles it finds and then summarizes them. And I just downloaded a Word doc from it. Nothing up my sleeve. This is exactly what the tool gave me. So it writes a summary. Is that not getting bigger? There we go. It writes a summary of the literature that it found. And it cites the literature that it found. And unlike some generative AI tools, we are 100% assured that these citations are real, that these PMIDs are real, and that they refer to the citation they're associated with. And that's because we don't let the generative AI write the citations. We pull these directly from PubMed, and sort of like a word bank, it can pick ones, but it cannot write the citation for it. And so that means we know that these citations are all real. I know for a fact that one of our clinicians is currently using this in efforts to write some book chapters. We're using it for a commissioned review article for a journal, and we will, of course, disclose it because the journal says we have to. But those are some real life use cases. And again, this is our second most popular tool currently. We have another one that if you read all of our warnings, and then answer 6 questions about a proposed research project, this will draft your human subject protocol for IRB submission. I've actually showed this to the IRB vice chairs, thinking that they might say, oh, that's a little scary. But their actual reaction was, wait, if it can write them, can it also read them? So that was an interesting thing that we may we would play with next. This one usually takes a second, so let me see if I can grab an example before it finishes. Box recently deprecated my favorite way of interacting with Box, and now I'm all turned around. Here we go. Okay, so that takes a while. It's going to write a 9-page protocol, so it's going to take a little bit. But what comes out of that is a Word doc, one with some important considerations, telling people they really have to review this, that they can't just send it to the IRB like this. We also had some IRB folks say one of the biggest problems they encounter is people don't really know what a data collection sheet is. And so could you just have this thing tell us all of the variables that are needed? And so actually our AI tool does 2 passes. It writes the protocol, and then it reads the protocol and lists all of the variables that are needed. We intentionally leave some things blank so we can catch people who don't edit it. But then here is the AI generated text. Again, I answered 6 questions. They're very short questions. And now I've got this somewhat narrative protocol. And if this was a prospect or a retrospective study, but if it were prospective or an intervention, it would actually take a real swing at a timeline. We've seen it do that. It even tries to talk about statistical considerations and what resources you'll need. And if you had used our literature tool, you can give it what the literature tool found, and it would integrate that into the document. Okay. Similarly, when we were working on the IRB drafter, we came across consent forms and learned that all consent forms are supposed to be written in an 8th grade language. So we made this tool that all it does, and you can imagine this is a very simple prompt, but it's also a little bit of a popular one, especially with our communications folks. If I put in a description of something at whatever language level I want, it will simplify it to an 8th grade reading level. Again, you could imagine the easy prompt to just go just with ChatGPT, but we found folks like that these tools are just here waiting on them. Related to that one, we have one that can take an abstract and turn it into a tweet. I refuse to call them X posts, a LinkedIn post, or just a summary that you might want to give to like a communications team or as part of a press release. And we've actually seen that our communications team, and now I think actually some folks from the broader UAB communications team are using this tool. We have one that I imagine everybody here is interested in. And I'm going to start this one running, and then I see there's some questions popping up. So this one, if you enter specific aims, it'll help you draft your specific aims page for an NIH style grant. We targeted our like Roger style grants. It'll also help you draft research strategies. So we'll let that one run for a second. And I see Dr. Zhang has a question. Or maybe you were just saying you want.
I made a mistake. I don't have questions.
Oh, sorry. There's a little icon on your next.
Yeah, that's right.
All good. So this one just finished. It drafted our specific aims page. I hit the download button. We again put, don't just submit this. The NIH says you're probably committing academic misconduct if you submit this without editing. We even provide a link to that note from them. We provide a link to Authenticate, so you can check this document for plagiarism. But here it took my aims were about a made-up microRNA drug that can basically cure Alzheimer's. So this is entirely fake, but this was my made-up specific aims. And you can see it wrote the specific aims page. It tried to write the project summary, although for those of you who have written project summaries, this is too short, so you would have to lengthen this up a bit. It can also help you with research strategy. This is probably our least user-friendly one. You have to come in this text box and enter a bunch of details, but it will help you write your research strategy sections if you want. And then we also have cached the last 5 years of NIH-funded grants according to NIH Reporter. In certain departments, we did have to limit it because of some of their API limitations. So relevant to our folks, in anesthesiology in particular, if you enter your aims, it will now compare your aims to the last 5 years of funded grants at the NIH, including renewals. And it'll tell you how similar or different your project is to other ones that have been funded. And that can go both ways, right? Sometimes the NIH really gets on a track and they just want to fund the same thing over and over. And so maybe knowing that your project is almost exactly like this person's would be beneficial. So you can see these all do seem related, especially these first two. Okay, one that was recently quite popular, as you can imagine, is if you will give our tool your CV. We have worked with mainly folks in radiology to understand what needs to be pulled out of CVs to write the narrative portfolio, or what was really, really popular recently, especially among some certain department chairs that I won't specifically call out. But we know that some department chairs use this tool to draft their chair letter for promotion recommendation. And so I put in my CV. Recently, I went up for promotion for teaching. So hopefully you all think I'm doing a good job. Otherwise, you know, we're putting to shame the promotion committee. And it will draft the recommendation letter. As you might expect, it's a little bit vanilla and it won't know about your personal experiences with this person. And so you will have to edit it. But what we've been told by those same department chairs who use this is it got them about 70% of the way. And so now we're saving clinical department chairs 70% of the time that they normally spend year to year creating recommendation letters. And those numbers get big fast. I'll show you the letter it drafted for me. I'm also super grateful that this thing is going fast today. Sometimes these tools are a little slow. So this is the letter it drafted for me. It talks about some of the courses I've taught. It talks about some of the guest lectures I've given. And these all seem generally true. Okay. Again, it can also help you put together your narrative portfolio. It's a cool thing you can do. We have just our own little sort of great value brand version of ChatGPT here. It doesn't keep conversation histories, but if you're a little wary of the commercial tool, want something a little safer that's on UAB blessed technology, you can come here and you can talk to ChatGPT. Our most popular tool that shocks me to this day that this is the winner is our meeting notes tool. And this is currently used across the institution. We know for certain the CMO's office even uses this. And we know that our perioperative services folks use this for basically every meeting that they're in. We have set up instructions here, but the short of it is if you're collecting transcripts from any Zoom meeting, you can come here, upload the transcript, and it will prepare meeting notes, including action items and then summary of what's relevant to those action items. Let me, come on, there we go. I have a sample meeting. You currently have to say there's no restricted data in here, though we're working with HSIS to remove that restriction. And it's going to summarize the meeting. The other one, let me just pull up a completed example. Oh, nope, it's being blessedly fast today. So I'll show you our meeting notes. And you're immediately going to think, well, doesn't Zoom have this now? Yes, Zoom does have this now. And I would love to just delete our tool for the Zoom one. However, we've built up quite a user base. And two, the Zoom tool is not yet approved on the health system side. And so as far as we are aware, our tool is the only policy compliant meeting notes tool, meeting notes AI tool for the health system side. I think that's going to change very soon. But at the moment, and at least as of my update last week, this is the only one that is blessed. Something that we tried out this year that is somewhat popular, and I know at least 2 departments are using this, is if you will have Zoom either in person or virtually, it doesn't matter which one you pick, keep a transcript of an evaluation meeting with an employee, and then you upload that evaluation meeting, and we have lots of notes here and instructions here and caveats for responsible use. But if you'll put in the supervisor and employee name and ask it to summarize the evaluation, it's probably not the best one. Here we go. It will produce this document. which one has some nice celebration of success that our department wanted to focus on, goal setting for the next year, et cetera, et cetera. But then what I think might be the sleeper real utility here is if you've used the UAB HR form, you should recognize all of this. We had a version that would suggest ratings. We actually took that out. We decided that was not safe or ethical under our definition of safe and ethical. So now it just lists the options for the rating. Let me see if I can find one that has it that way. Yeah, this is our newest version. So we leave the rating options, but those comments that you have to go write in the HR tool, it pulls those out of the meeting that you had with the person. And so now you can go copy and paste these, or maybe have an admin help you copy and paste these into the HR tool. I know that at least 2 departments using this for their evaluations this year. And yeah, we even worked with HR to make sure you were following all the policies as we did this. And the last tool before I pause for, I'm glad we're going to have time for questions. I feel like sometimes I talk too much. This is actually not an AI tool, funny enough. But if you come to this page and upload an XLSX or a CSV, or if you just want to use our example, I've got an example here. We have, again, a essentially Walmart Great Value brand. Walmart's not affiliated with any of this version of Tableau, which, as I understand, has become quite expensive lately. So I don't even remember what the numbers are in our example data set. But if you upload a data set, it lets you make pretty plots. You can change the style of plots. I even remember how to use the tool. It can be an area plot, it can be a line plot, it can be a bar plot. And you can get pretty fancy with the ways you can manipulate this, just like you can in Tableau. All kinds of settings you can use. And at the end, you can download your publication quality figure to send it. We've also added, along that same line, a data analyzer. Again, there's no AI involved. This all stays on our department servers, and our department servers live in Green Services Building, which is PHI safe. So this tool is even technically PHI safe, though we do ask you to de-identify it just in case we've missed anything at the moment. But you upload data, and what this does is it will give you some univariate analysis, just telling you about each element in your data frame or in your spreadsheet. It'll also look at interactions among the data, and it'll give you some details on correlations in your data and missing values. So probably the least exciting tool, but it's a nice little first pass for data analysis and visualization. All right, so that concludes my demos. Let me jump over here. I will, just like I advertised for waveform data, say our department also has a funding mechanism for developing AI tools. And so if that sparks any interest and you can get an anesthesiologist interested in your idea, we will dedicate 6 weeks to selected projects. That's all our team works on. Currently 3 people, about to expand. We give $5,000 for publication, travel, conference, if there's any computational costs. But I will say the computational costs are relatively low. I think the most we've spent building any tool was $500. And if you have a clinical champion on your project, they get 1 guaranteed non-clinical afternoon a week for 6 weeks. So we work with the scheduling folks to make sure we can guarantee that. And we're picking up to 4 projects a year. The next call for applications will be in February 2025. So if you have an AI idea related to any of the things or spun off of any of the things that I showed you, and you can get an anesthesiologist interested, you can essentially get 6 weeks of my team's time dedicated to that project, along with a little bit of money. All right, so with that, I'll thank the other folks on my team, Ryan Godwin, who's here, Kamashwari, who I'm not sure is here, my department. And just to remind everyone, these are all of the tools I just demoed for you. And so with that, I'll pause and take any questions. All right.
A lot of questions in the chat. If you want to start with those.
Yeah.
Thank you very much. Very enlightening and presentation. It almost makes me feel like I could, basically it's like a clone of myself, or your like virtual team, like an AI team that's helping you be more effective.
Yeah, I imagine if people start using this, our grad students will be a little less stressed, right? All right, let's see. Okay, some of these were in context and I don't. So how does your tools relate to scholarly specific AIs like Elicit? So I think if you're doing a meta-analysis, Elicit wins. And we're not necessarily trying to compete with Elicit. I think there are some really cool things in Elicit. If anybody hasn't used Elicit, and it's actually spelled with an E if you try to find it, ELICIT, it will search PubMed and I think Web of Science. So they do a little broader than us even, and present you all the articles they find in a nice little spreadsheet in a window. And then what you can do is you can add columns to the spreadsheet and the AI will fill in the columns. So let's say you wanted to do something on, what's a controversial one? Let's get fun. On pericarditis after COVID vaccination. So you could just search that, and then you could put as your additional column, what was the effect size? And it'll actually read the articles and try to fill in the effect size column from each of the articles. Or you could say, what was their sample size? And it'll fill that in. And so you can see there's some real power in Elicit for things like meta-analysis. Our tool does two specific things, and we think it does them really well. It'll write you a one-page summary of the first 50 articles it finds in PubMed, and those are ranked by PubMed's importance ranking. So we'll just wave our hands at that for the moment. And it'll write a summary of them, or it will walk you through all of the steps of writing a scoping review. And at the end, it will actually produce an AI first draft of your scoping review that is often quite long. So I think we've gotten like 12 or 20 page reviews out of this. All right, with Zoom transcripts and hybrid meetings, many speakers end up on one microphone. All right, we have a solution for this if it's a one-on-one meeting. So if you set a laptop in the room, turn on Zoom transcripts, it will, just like Curtis has said in the chat, it will say that everything that is said was all said by the same person. And I think that's what he's pointing out, like the transcript will look wrong. And actually, I have examples of this. So let me just pull this up, what Curtis is describing. Okay, so, oh, that's so tiny. Oh, my Windows snap thing isn't working. Okay, so I was not in this meeting, and yet it's using my name, right? Because I set up the laptop that was in this meeting. This meeting was actually with Dr. Thompson and Dr. Smith. That is why in our one-on-one meeting tool, we asked that you tell us what the right names were. And then this seems real dumb. This was actually the idea of a person on Reddit, and it almost magically works. We tell GPT-4 Omni, the current smartest model from OpenAI, what the real names of the people speaking were. We tell it that the names in the transcript are wrong, and we tell it to correct the transcript. Now, what's interesting is you don't actually care if it does that right. All you care about is whether the meeting notes at the end are useful. And so when it corrects the transcript, it's getting it close enough to make useful meeting notes in our experiments across 2 departments so far. So Curtis, we are aware of that limitation and can solve it for one-on-one meetings. We don't have a solution if you did this for like 3 people or more. All these tools currently available for use. This is from Emily. Yes. And Ryan provided the link, or I provided the link, and Ryan said to email him. So I think that leads to Curtis's next question. Why are you limiting this to Blazor IDs? And that's because we actually have this website exposed to the world. And so anyone could access this website. Oh, I see. I didn't share that with everybody. Let me share it with everybody. Whoops. Nope, that's not what I wanted. Okay, I'll try to do that again in a second. This is currently exposed to the world, and every time someone pushes one of these buttons, it does cost my team a small amount of money. So we're just not letting the whole world use them. We're letting people with specific Blazor IDs use them. I think maybe you could argue, well, why don't you let everyone with a Blazor ID use them? And our fear there is that just all students everywhere would use them at once and we would go broke. So that's why we're making people send us a request for access, and we're saying yes to everybody, but we're at least slowing down the the influx. Ryan, any thoughts on how to best manage multiple projects with multiple funding sources, given the constraints of Azure building? So that's from John Osborne. There's a solution coming on the HSIS side. I know that. So they are working hard on, you'll have subscriptions, and then you'll be able to ideally link tasks to certain GL numbers. So John, I think an HSIS side solution is coming. I don't know if a campus side solution is coming. And John's question is a good one, because if you use the UAB Blessed Azure, you provide one GL number and everything you do on it is billed to that one GL number, and you actually can't set limits. So you can set a thing that will flag and email you when you've spent, our budget is currently $120, we should up that, we blow past that the first week of every month. But it'll just email you and say, hey, you've gone past your budget, but it won't actually do anything on the Azure side. It won't stop you. All right, I think Jake has a question, a live question.
Yeah, very useful tool. I wonder if you're mostly using the prompt engineering, or you actually fine-tune the model to make it more specialized. For example, developing an IRB protocol that, if a UAB has many IRB protocol that serve as a good example, do you fine-tune the model, or do you just still use the raw ChatGPT behind the scene?
Yeah, let's go through this. So we have done no fine-tuning. We thought we would have to. And I think this speaks to the surprising versatility of some of these tools. So let's just go through. So this first one is retrieval augmented generation. So this is just doing a search and then including the results of the search in the prompt to the AI. This one is pure prompt engineering, and it's actually a couple of steps that happen. So it's not just one big prompt. It's construct a query, and then we programmatically use that query to do a PubMed search, evaluate that search, potentially write another query if that search was not sufficient, then programmatically do the search, read the results of the search, download the abstracts, and if available, the articles, summarize what you found. And so there's like 4 levels of prompting going on. IRB draft, prompt engineering and some micro examples of different parts of what goes into the IRB draft. But we were again surprised that we just took the IRB's description of what needs to go in every section and told that as part of our very large prompt. And it's doing a good job.
So these are essentially workflows with very sophisticated prompts and contextual documents.
Yeah. And it's stringing together generative AI and conventional code. And I actually think that that is the current best way to do these things. I have seen so many people talk about how great AI agents are, and I have yet to have one actually accomplish a task I gave. And so we could have said, here is a query, here is access to the internet, do a literature search. And instead we said, oh, well, if you do these 4 things, then you have successfully completed a literature search. Some of those 4 things are best done by generative AI, and some of those 4 things are best done by code. Yeah, that's a great description, Curtis. So Jake, does that sort of answer your question? Our grant preparation one does have examples. Most of these tools have been open sourced. We had to change the version of the code we put publicly on the grant one, because we do have real grant examples in here, and some of those we don't actually hold the copyright on. So we did not share those with the world, but they are examples to our tool. Again, prompt engineering. And
So is that to say that when you say the tool is publicly available, that means it's on GitHub just without the necessary data? Or the example grants in that case?
Yeah, what we did for the publicly released code was we had ChatGPT make up examples to use. Its turtles all the way down. But yeah, we have these on Git, and I think one of the links I had maybe went there. Let's see which GitHub I'm logged into. I might be logged into my personal GitHub, or neither. So yeah, our team has a publicly open GitHub account that we did get approved by UAB Communications. And we have the template that we use for building all these tools that Ryan Godwin is the main architect of. And then we have many of those tools like the grant guide we just talked about, the IRB Assistant, CD Promoter. This is the one that helps you write recommendation letters. Open sourced under GPL v3, which is what the HIIE folks told us to use. So we're trying very hard to just follow all the policies all the way down, because we're just afraid someone will come along and say you have to stop. And it hasn't happened over the last, oh gosh, I guess 18 months. No, year, over the last year. We've been doing this for a year with these tools.
It seems like a lot of this stuff is not specific to the sort of department or the group in which you're embedded and that's funding this. Is there a conversation about providing funding to make this more generically available and more of an institutional tool?
I have tried, and I don't know the right people to talk to. So maybe if you have advice, I'm happy to hear it. So I've talked to the director of HIIE, Karthik. He told me that he thought they could offer funding. He asked me for some follow-up. I gave that. And then I'm not exactly sure what happened. I don't mean to air dirty laundry. I'm just telling you I've tried. And then I've also talked to INHIBI, the Marnie Heersink Institute for Biomedical Innovation. They similarly said, yes, we're interested. And then I got no follow-up. So I'm at this point concluding I'm bad at holding people's attention. If anybody has access to funding and wants to make these more broadly available, I will take your money all day long. Let's see.
Can I ask another follow-up question? So I think a lot of the features are very good for our UAB people. And then there are equivalent paid commercial options such as Perplexity and Cloud and many other tools that we use separately, right? You have to pay some money, like usually $20 per month. Have you looked at the quality and the cost effectiveness of purchasing other tools, not having to maintain versus using your tools to build a really compelling case? Because you did mention that 1 week it's you're spending $120, and that could be a concern. And I also know that even for Perplexity, it gave me the PubMed ID, and when I actually said, well, generate these, and then it will generate even with the PubMed ID, even with a retrieval augmented searches, a fake publication. That is quite a concern.
Yep. That is why we built our tool the way we did. It cannot generate the citations. It can pick citations, but it cannot generate them. Because yes, I have experienced the same thing. I've gotten a very convincing PubMed ID, a very convincing citation, and sometimes the PubMed ID is real, but the thing it goes to is unrelated to the citation it gave me. So that's happened on other tools, just to be clear. Again, our tool, the AI is not generating the citations, it's just picking them. And so that's why we know they're real. And if you want to go look at our code, that's one of the publicly available ones. You can see that it is like exactly what it's doing and how we know, like logically guaranteed that those citations are real.
In terms of a cost issue,
yeah, sorry, that was your original point. We have done a little bit of ROI, and I will tell you, we've got a range, and the range goes real big if we want it to. But I think our most honest assessment is over the last 6 months, we've probably done about $600,000 in value creation. I would love to say $600,000 in money saved, but I actually think most of the tasks done with our tool would simply have not been done. And I've got this big spreadsheet. You could go over my numbers if you want. I'm happy to share them with anybody. But that's why we're not saying we've saved that money. We think we've created value because we think some of these literature searches just wouldn't have happened, for example. As far as comparison, the closest one I have is I know our pain clinic was considering spending like $1.5 million on a patient note-taking solution from Microsoft and Nuance. And we have now replicated that exact solution. It took us 2 days, and it costs about 50 cents per patient interaction. So We could save that money. Although I've been told by the business folks in HSIS, the space is too crowded. Essentially, other companies have already won. Anyway, so we do have some cost comparison to answer your question. I will say we are getting overwhelmed with trying to maintain these tools, build new tools, and do the original job my team was like charged with, which is more data science. And so we are going to start costing more because we need more help. I'd love to hear, Jake, if you have ideas on how we can better make an argument and assess our value.
Yeah, it's an eternal theme, buy versus build. And that's, yeah. Thank you.
Yeah, thank you. That was a very long-winded answer, but thank you for asking. Let's see, what else do I see in the chat? Ryan answered the one about Streamlit. Have you considered integrating API tools like connected papers? So we have, and we often get pushback from the information security folks about adding additional functionality. So for example, we wanted our grant tool to automatically submit to Authenticate and give you a plagiarism report as part of its output. And that's a thing Authenticate can do. They have the API. They just needed someone from UAB to say, yes, we agree that you can use the API on our account. And no one would. I tried to chase down several folks, and the word AI just scared them away, and they stopped talking to me.
Quick note that we are at time, and we still have over 30 people still signed on, so that speaks to the interest. So if anybody wants to, I don't know if Dr. Melvin can stay on a little bit longer, if anybody else wants to, but I don't want to force anybody to, since we're officially at time.
I can stay around for a few minutes. I see SN asked a question, privacy issues. So the data is sent to Microsoft Azure, but it's under a BAA with Microsoft Azure, which is the same sort of agreement that you have to have for transmitting patient data. So I would say that we are at this point on a fully HIPAA compliant stack. And so we're considering that good enough for privacy issues. We are trying to only send what we have to, like with the CV tool. We don't send your entire CV. We have a somewhat sophisticated set of search rules that based on what you want done with your CV, it will just do a local search and pull out the important elements. And those are what get sent to Azure. But yeah, the data is leaving campus. The data is stored on Microsoft servers for 30 days. That is what's happening. Yep. So if you will email me or, the person who asked for access, if you'll email me or Ryan Godwin your Blazor ID and tell us that's what you're asking for, we will add you to the list. It usually takes a couple days for it to work its way through the system. But ideally if you email us today, you probably would have access on Monday.
Yeah, kind of following up on that issue of getting access, like if you can remind me, how are you currently funding all that processing? And if it's that useful or even essential for our community, and the CMO is using it, how can we, or are there talks about making that more widely available and then having some larger, maybe enterprise-wide funding mechanism?
Good questions. This is coming up more and more for us. We are actively talking with HSIS about our tools and how they're doing, how they're getting set up to bill when they let the health system side start using Azure for patient data. I'm hoping we can integrate some of that because it's a good point. Amy, we're currently paying for it. So this is all paid for out of my startup funds at the moment, which is fine. We're very happy people are using it. So please, no one be afraid to use it because I've said that. Because the more you use it, like I would love this thing to be used so much that at the end of this month, you've spent all my startup funds. Because if that happens, then I can go to my chair and I can go to the dean and I can say, look at how popular this is. And it's about to go away unless you give me money. So I would love to have that problem.
Yeah, but you shouldn't be using your startup funds to function as a public utility, essentially. That's great. That's altruistic, but and also everybody's using it makes it better. But to sort of sustainability and scalability and building up, then yeah, it should be like a line item on the university or health system's budget that hopefully that it's moving in that direction. But sounds like it is.
Yeah, I want to move in that direction. And I also am trying to make the argument that, look, we can't, it's not just the compute cost, it's the time and effort to maintain these things, to respond when someone says, hey, it's broken. Or when someone has a really great idea of how to improve one of the tools. Right now, we write it down, and a few months later, we might get to it. But we just have like a whole list of duties on top of this thing that we essentially built because we knew we could and we thought it was neat. None of this was in any of our original job descriptions.
Any final thoughts, comments, questions?
Hey, Dr. Melvin, it's Nathan Hutchinson. How are you?
Hi, Nathan. Yeah, I saw your message, and please email me.
Yes, absolutely. So everybody else on here. So I actually work for Microsoft. Came from Nuance. We were acquired by Microsoft. And our solution is called DAX, Dragon Ambient Experience. And we are doing a lot of the things that you were talking about in the clinical engagements with providers and patients. Right now, just in the ambulatory side, but we're quickly moving into the inpatient to include surgery and all the other clinical patient engagements that you typically would see as a physician. So it would be great to get involved with you guys. I'm actually local. I live just south of downtown Birmingham. So.
Oh, great. I went to dinner with some Microsoft Nuance people at Helen. Were you there, maybe? Have we met?
I was not there. No, sir, I was not.
Okay.
So,
yeah.
And we'll be at the symposium next month talking about cybersecurity and the healthcare environment. So.
Okay. Great. Yeah, please, let's connect.
Perfect.
And Nathan, thanks for joining and engaging in discussion. Can I ask how you found out about this? Is because you're local in Birmingham and keep up with the UAB scene, or
I do, and I've been working with UAB in multiple different areas and companies since about 1999. So I started out orthopedic spine implants and moved over to the technology. I worked for GE Healthcare for a while. You guys have a lot of GE imaging equipment that I sold you guys. So, and I got recruited over to Microsoft about 3 years ago. So.
Oh, okay. All right. Well, great. Glad you joined us.
Yep, I keep up with you guys regularly.
I hope it leads to some fruitful collaboration.
I agree.
Any other final thoughts, comments, questions? We have almost 20 people still on, and I know that probably Dr. Melvin probably has other places to be, but everybody's here. Just anybody had any final thoughts, comments, questions? All right, well, hearing none, then thank you all for joining us. Thank you, Dr. Melvin, for kicking off our PowerTalks series. Be sure to join us. We have a lot of great speakers lined up, and everybody have a great weekend. And I think we all looking forward to having these set of tools help us be more effective, do more research stuff. All right, well, thank you, everybody, and take care, everybody. Bye-bye.
Bye.